Assalamualaikum to all of you. So I will start my lecture for chapter 1. So chapter 1 is about subsurface exploration or site investigation. So it is including site investigation and in situ testing. Okay, so this is our detail about this code. I have explained it earlier. So this subject is 2 credit unit and ECG 243 basic soil mechanics is prerequisite for this subject. So for textbook, I'm using this one. So this is the same textbook as your basic soil mechanics textbook lah. Okay, so this is our course outcome. So there are 2 course outcome for this subject, and then there are also 2 POs or program outcome for this code. So for course outcomes, this subject is at the end of this semester, you should apply knowledge of soil engineering concept, respond to various geotechnical situation, and then number 2, measure solution for soil engineering problem. So this is the problem solving lah, with the design system, component or process to meet specified need with appropriate consideration for safety, environmental consideration. Okay, so the first course outcome is more to the knowledge of soil engineering, okay, the basic concept, and then the second course outcome is more to the problem solving lah. So how you are going to solve the soil engineering problem. Okay, so the CO1 is mapped to PO1, okay, and then CO2 is mapped to PO2, okay, for your program outcome. Okay, so this is a learning outcome for this topic. So at the end of this topic, students should be able to discuss the purpose of site investigation. So it is consists of scope and objective of site investigation. So you should know why we conduct site investigation and then what is the scope of site investigation. And then number 2, categorize site investigation method. So this is the exploration technique. Okay, so how you explore the site. So consists of boring. Okay, so there are various types of boring method, boring technique, and soil sampling. So how you are going to take the soil sample. Okay, so you are going to take the soil sample and then test the soil sample so that you can get the soil properties lah that is useful for your design. Okay, so there are sampling technique to do that. And then number 3, propose the suitable site investigation method for different cases. So at the end of this topic, when you have gone through all of the procedures, so you should be able to propose, okay, what is the type of investigation that is suitable for your site condition. Right, so number 4, execute and interpret site investigation data for in situ testing. Right, so for site investigation, you can conduct the test directly on site. Okay, so we call it as in situ testing or field testing. So there are various types of in situ testing. So means that you can get the result or get the soil properties directly from site. Okay, that is field testing lah, or in situ testing. Or you can also take the sample and then you can bring the sample to the lab and conduct testing lah. So that is laboratory testing. Okay, so that testing also included in site investigation. And then last one, propose suitable construction, okay, or SI from acquired data. Okay, so you can propose what is the suitable method of construction from your SI data, right? For example, when you go through the SI report, and then you know what is the soil properties, and then you can propose what is the best foundation system for your construction. Okay, for example. Okay. Okay, for introduction, subsurface exploration is a part of site investigation. So we want to explore what type of soil, and then what are the properties of the soil subsurface. Subsurface means it is underground, okay, below your ground surface. That is subsurface. So we want to explore your site. It is also called as site investigation. Site investigation means you investigate. So you gather all of the information about your site, and then you analyze, and then from that you can propose. Okay, you can propose what is the best construction method, okay, for your project. Okay, site investigation in general deals with determining in general the suitability of the site for the proposed construction. Okay, so any type of construction, either you want to construct building, you want to make road construction, bridge, and so on. So every design or every construction, you need to do site investigation. Okay, you have to know your site first, you have to know what is your soil properties first, and then you can proceed with the design, and then you can construct your building. Okay, you can start with your project. Okay, attempt and understanding the subsurface conditions such as soil and rock. So you have to conduct site investigations, so you can explore your site, so you can identify what is the soil and rock that you have underground, okay, on your site. So you can get the overall picture, okay, what is your site all about. And then number 2 is geological features. So you can identify what is the geological features of your site. Position and variation of the groundwater table. So it is very important because soil strength is depending on the water table. Either your construction is above water table or below water table. So you have to locate, you have to check where is the location of water table on your site. Okay, physical properties of soil and rock. So it is very important because your design is based on the soil or rock properties. Contamination, if any, so you can check also on your site if there is any contamination. And then general data of adjacent structures. So you can collect and gather all of the relevant data for your site, okay, such as the hydrological data, the maps, and so on. So you can gather all of the information, and then you can analyze from that. Okay, so from that you can use all of the information together with the soil and rock information so that you can proceed with the design. Okay, purpose of subsurface exploration is to obtain information that will aid the geological engineer in number 1, site assessment. Okay, how you are going to explore the site. Okay, safe and economical design of temporary and permanent work. So all of the information for site investigation will aid site engineer to start the construction process. So they can choose what is the best economical and safe design for temporary and also for permanent work. And then number 2, planning and assessment of construction method. So from that also the geological engineer or site engineer can plan what is the best construction method or technique for your work, right? So based on site investigation data. And number 3, foresee construction difficulties. Okay, from subsurface exploration also you can foresee what is the biggest challenges, okay, for your site. What is the biggest problem that you will foresee, okay? for your construction, okay, or during your construction. So you can predict, and then you can prevent, or you can handle the problem. Okay, number 4, choice of site layout arrangement. Okay, so site layout arrangement is based on your geological profile, right? So you can arrange the layout depends on your site condition. Okay, it is all from your site investigation data. Okay, next is objective of site investigation. So there are a lot of objective of site investigation. So based on the British standard also, there is a list of objective of site investigation. Okay, so that is the main idea why you need to conduct site investigation. Okay, so here I listed around 5 objective of site investigation. So number 1, to assess general suitability of the site for the proposed work, including implication of previous use or contamination. Okay, to assess the general suitability of the site. Number 2, to enable an adequate and economic design. Okay, as I've mentioned earlier. Number 3, to plan the best method construction and foresee and provide against any difficulties. Okay, so you can handle the problem because you can foresee what is the biggest challenges that you are going to go through, okay, during the construction. And then number 4, to determine the changes that may arise in the ground and environmental condition and the effect, okay, and the effect of the such changes on the work, adjacent work, and on the environment in the general. Okay, so you can determine the changes that may arise, okay, during your construction and also after construction. And then number 5, to advise on the relative suitability of different sites. Or different part of the same site, okay, to advise on the relative suitability of the different sites. So you can propose what is the alternative that you have. For example, you have that certain problem, so you can advise what is the alternative. So you can choose what is the suitable, what is the suitability of your design for different sites. Okay, next is stages of site investigation. Okay, so it doesn't matter whether your construction is big, moderate, or small construction. All of the construction work, you have to follow you have to conduct the SI. Okay, so this is the stages of site investigation. So it's starting from desk study. So desk study means that you gather all of the information and then you analyze that information. Number 2 is site reconnaissance. Site reconnaissance is conducted by the site engineer. You have to go to the site and then you have to observe the site. Okay, so that is site recognition. And then next is detailed site exploration and sampling. So you have to conduct testing. You have to explore the site. Okay, depends on your type of site. So you have to select what is the best exploration technique for your site, and then you can start exploring your site. And then after that, you are going to take sample also, so that you can bring it to the lab and then you can conduct further testing. Right, and then next is ground exploration. So you're starting explore your site, and then lab testing. And then after lab testing, preparation of SI report, design and review during construction and monitoring. Okay, stage 1, it is desk study or preliminary work. So desk study is collecting general information and already existing data. Okay, so you gather all of the data such as the maps, the topographic map, the information from local authorities, all of the records that you can find for your site. Okay, so you can also study the site history, for example, if previously used as quarry and so on. Okay, so this is all of the information that you can gather, right? So the site history, the land use, okay, so that is the history of the site, the geological map, the topographic map, result of adjacent nearby ground investigation. So if you have construction nearby, you can ask for the detailed site investigation, so you can relate it to your site. Okay, the aerial photograph and so on. Okay, so this is all of the maps, geological map, aerial photograph, or topographic map that you can gather lah for your site. Okay, during the study. Okay, next is stage 2. It is site reconnaissance. It is actual site inspection. So it is done by site engineer. So site engineer will go to the site and then observe the site. So he can confirm and obtain additional information, examine adjacent and nearby development if any. So he can observe lah what is the adjacent construction or existing construction that you might have around your area, your site area. Compare the surface features and topography with data obtainable in their study. So he can check and then he can identify lah the actual features of your site. Locate and study the outcrop, the previous slip, and so on. Okay, so he will observe all of the detail that he can see lah on your site. Okay, the topography, the type of the site, and so on. And then he can identify lah whether what is the size or what is the type of exploration plant or equipment that is accessible to your site. Okay, for example, if your site is in the jungle, so what is the best exploration? Okay, so what is the type of equipment that you can bring it to your site? Okay, so it is depending on your type of site. Okay, so this is the picture. The actual site inspection has been done. Okay, so next is site exploration and sampling. So it involves preliminary investigation, detailed investigation, depth, and spacing. So for preliminary investigation, exploratory boring or shallow test pit, representative sample, geophysical investigation. Okay, so you start to explore your site. Okay, so you can select, there are various type of exploration technique, for example, boring, trial pit, and so on. Okay, so you can also take sample for sampling, and also you can conduct geophysical investigation. Geophysical investigation is non-destructive technique. So there are also few techniques how you can get your site detail without undestructive, okay, without apa nama dia, damage the structure of the site, okay, or your soil. Detailed investigation is deep borehole, okay, extensive sampling, in situ testing, and lab testing. Deep borehole means that you have to advance the process. Kalau preliminary investigation, maksudnya it is not too far from the ground surface, but detailed investigation, you have to detail out, you have to advance the borehole, okay. And then depth and spacing. In general, depth of investigations should be such that Any strata that are likely to experience settlement or failure due to eroding. Okay, due to the site investigation, there is the guideline lah. There is a guideline. What is the depth and spacing of your borehole? Okay, so for example, if you design for critical structure, for example, you design for the hospital, the depth and spacing of the borehole should be more, because the construction is very important, it's very critical. So instead of selecting the depth from one borehole to another borehole is far from one another, but for critical construction, for example, hospital building or construction near to the slope. Okay, so it is very critical because the safety is very critical. You want to design something near to the slope. Okay, so the safety is very crucial. So you have to conduct a very detailed site investigation. So the depth and the spacing of site investigation should be more. Okay, the number of site investigation or the number of boreholes should be more, and then the depth should be very far, okay, until the very hard layer of soil, and the spacing should be less lah from one another. Okay, the borehole. Okay, so next is method of sampling. During site exploration, so you have to take sample. So this is some of the sampler that we have to get the soil sample. So we have various type of sampler here. So we have open drive sampler, thin wall sampler, split spoon sampler, piston and Messier sampler, right? So all of these sampler, it has its suitability for certain type of soil. So you have to check lah. For example, for open drive sampler, it is suitable for cohesive soil, and for thin wall sampler, it is suitable for different type of soil. Okay, and then other thing that is very important for this sampler is the disturbance. So normally for soil sample, we want to get the best or the less percentage of disturbance. So every sampler, it has a percentage of disturbance on its own, right? So in general, so the thinner the wall of the sampler, the less disturbance that the sampler will produce. Less disturbance means that you will get more accurate data lah, okay, for your testing. If the soil is very high in disturbance, so maybe the data that you can get from the testing is not so accurate. Okay, so less disturbance means you will get more accurate data lah, because it is less disturbed. Okay, so this is some of the picture of sampling. So this is using a thin wall sampler, and then this is for split spoon sampler, I think. Okay. Alright, so this disturbed and undisturbed sample that I've talked earlier. So disturbed or undisturbed soil can be retrieved from site to be sent to the lab for testing. Okay, undisturbed means without disturbing the natural condition of soil, such as its structure, texture, water content, and so on. So we would like to preserve the soil condition as on site, as it is. So we do not want to disturb much its structure and so on, right? So it will represent the actual data. It will represent the actual condition of the soil on site. Okay, so it is undisturbed. So how to produce undisturbed sample? So this is some of the sampler that we can use lah. That will produce less disturbance to the soil sample. For example, we have piston sampler, thin wall sampler, continuous sampler, or Messier sampler. Okay, so disturbed sample pula, So when natural condition of a sample such as its structure, texture, density, water content, or the stress condition is disturbed, is disturbed lah. So means that there is something in the process of taking the soil sample will disturb, okay, the properties of the soil. For example, for split spoon sampler, the wall of the sampler is very thick. So the friction during the penetration of the sampler into the ground will disturb the soil, right? It will disturb the soil around the wall of the split spoon sampler. So it will reduce the percentage of disturbance. Sorry, it will increase the percentage of disturbance. Okay, so this is some of the picture of soil sampling. Okay, so this is some of the core that we can get from sampler. So the core will set in paraffin wax to preserve them. So we apply wax to preserve the soil sample so that the condition is intact for laboratory testing. Okay, so this is loose sample. If you can see here, we cannot maintain the structure of the soil because it is loose. So this is 100% undisturbed sample. For example, gravel or sand, it is loose material. It cannot have a certain shape when we cut the soil or when we penetrate the sampler into the soil. It has no general shape. It is loose condition. So the percentage of disturbance is very high. Okay. So the process of boring, driving the coring tool, raising and withdrawing the coring tool, extruding the sample may give some degree of disturbance, right? Next is laboratory testing. So all of the sample that you gather from the during the exploration, you can bring it all to the lab and you can conduct testing. So all of the testing, as you have learned before in soil laboratory in part 4 last semester. Okay, so you can bring all of the sample and you can conduct the testing. Depends on what type of parameters that you want. For example, you want to check the strength parameters, so you can go for shear board test, you can go for triaxial test or CBR test. And then if you want to get the classification, the physical properties of the soil, so you can go for the specific gravity, plastic limit, liquid limit testing, and so on. Okay, and then we have also chemical tests to check the type of chemical or the pH value that you have in the soil, and there is other tests lah. So you can list and then you can select, okay, what is the parameters that you want, and you can check what is the testing, okay, for that parameters. Okay, other than lab testing, we have also in situ testing or field testing. So there are various types of field testing. So field testing means that you can get the data directly from the site. You can get the soil parameters or the soil properties directly from the site. Okay, such as SPT is for standard penetration test, and then we have cone penetration test. We have vein shear test, piezometer test, dilatometer test, JKR probe or Macintosh probe, or geophysical method. Geophysical method is non-destructive method. Okay, we use wave nuclear to get the soil properties. Okay, The next stage is reporting the result. Reporting the result, after you get all of the information that you want from all of the testing, either field testing or site testing, you can describe your soil condition. Okay, what is the topography, the hydraulic condition, okay, what is the existing structure that you have, okay, supported by the plan, drawing, maps that you have. Right, next you can describe the nature, the type, importance of the proposed construction. Description of field and lab testing, so you can detail out what you have conducted in the lab and on site. And then you can analyze, and you can also discuss on the collected data. So you can prepare all the chart, table, graph involved. You can perform all of the calculation needed. And then last one is the recommendation. So you can recommend what is the best for your site, okay, based on whatever that you have during site investigation. Okay, stage 7 is design. So based on the report, proposal, site visit, lab, and in situ testing, a preliminary design can now be started because you have all of the information that you want. You have all of the soil properties, you have the soil strength, okay? You know what is the soil on your site, so you can start doing the design. And then stage 8 is review. From preliminary design, turn the approval design, then the project can be constructed, right? So you can start the construction process. Next is method of site investigation. Method of site investigation is method of how you explore your site to get all of the detailed soil or rock that you have on your site lah. Okay, so there are various type of method of site investigation. So number one is trial pit. Trial pit is a simple procedure. It is done by excavation. And then number 2 is hand auger. Number 3 is using borehole. So you advance the borehole into the ground. So there are various type of procedure. Number 1 is using percussion rig. Number 2 using rotary drilling or using wash boring. And the last one is rock coring. Okay, so the first site investigation method is using trial pit. So what is trial pit? Trial pit is simply dug using excavator or by hand. Okay, so we can use excavator to expose the ground. Right. So trial pit will provide easy visual inspection. Means that when you excavate, you will expose the ground. So you can see the soil layer exposed by the excavation process. Okay. But the main disadvantage of trial pit is the depth. We can only advance the observation by 2 to 3 meters only, right? We cannot go more deeper than that, okay? Because it will be more dangerous because it has tendency to collapse. So the depth is only up to 2 to 3 meters, right? Okay, side of trial pit have to be adequately supported. Depends on type of soil. So if the soil is very stiff, so it can remain its condition unsupported, so it's okay. But if the soil is very soft, so you have to provide something to support the exposed soil lah. Okay, so it is useful for soil containing boulders, cobbles, groundwater observation, and locating buried services and so on, right? Okay, and then you can also take the soil sample from the trial pit, right? So you can simply dug and then take the soil sample, or you can cut. You can cut the soil into a block sample and then you can take out. Okay, so trial pit is normally suitable for cohesive soil or soft rock and for soil above water table. Next method of exploration is using hand auger. Hand auger is a very simple hand tool for drilling into soft soil. It is manually operated, so the maximum depth of advancing the exploration is up to 5 to 6 meter. Okay, hand auger consists of 100 mm diameter of half cylinder clay auger. Alright, so this is the half cylinder clay auger attached to a cross piece through a different length of 1 meter extension route. So it has many extension route, and then we connect from one extension route to the other extension route. Right, we join the extension route together, and then we can advance the exploration deeper. Right. Okay, and from hand auger we can get the soil sample either by when you advance the hand auger, it will rotate it into the ground, and then all of the soil will come out during that process. Okay, from that we can collect the soil sample, and then that soil sample we can call it as a disturbed sample. Okay, another procedure is using sampler. Okay, so we replace the clay auger, this is the clay auger, with a sample tube attached to a sliding percussion link. So this is the sampler. So we take out the clay auger, okay, with the extension rod, and then we replace the clay auger with the sampler, and then we insert it back into the borehole, and then we drive it, and then we rotate it to apply shear, right, so that it can advance into the soil, and then we can take it out to get the soil sample. Right, so that is hand auger. It is manually operated. Okay, next is auger boring. It is simple method of exploration and sampling. Okay, so this procedure is more unlike hand auger. Right, so auger boring can be power driven or hand operated. Right, it can be done manually or it can be done mechanically by using power. Okay, suitable in all soil above groundwater table, but only in cohesive soil below groundwater table. And then the depth of exploration is around 5 meters from the ground surface. Okay, so this is the picture of hand auger. This is the hand auger on the right side, and then this is the auger boring. Okay, either manually or mechanical operated. Okay, mechanical operated means that it require the power of the machine to advance the borehole into the ground. Okay, if manually operated, you have to use your own energy. Okay, so you have to lower the handle, means that you have to hold the handle, and then you have to press it on the ground, and then you have to rotate it. Okay, you have to rotate it so that it can advance into the ground. Okay, it's the same like hand auger lah. So it has a handle on top, so you have to penetrate, you have to apply some energy so that the clay auger will penetrate into the ground, and you have to rotate it. Okay, so it will penetrate. Okay, so this is the log report. Okay, the boring log from the hand auger. So you can record the detail into the logbook lah. For example, if you take the soil sample, so you can write down the depth of the sample. Okay, make sure you have to put in proper container lah. You put in the container and then label. So what is the depth, right? So that you can describe it more detailed. Okay, for example here, okay, they describe it as silty sand and so on, right? For further observation. Okay, so next is borehole. It is include boring, sampling, in situ testing, and also water table observation lah. Okay, in the borehole. So you have to drill through soil and core through rock. Okay, if your site involve soil only, so you have to drill inside the soil lah. It has rock, so you have to core into the rock, right? So the cutter bit will be different, okay, for soil and rock. Okay, so there are 3 commonly used methods to advance the borehole. So number 1 is using rotary drilling. Number 2 is using wash boring. Number 3 is using percussion rig boring. Okay. And then next, in situ testing also can be done in the borehole. So using the borehole, you can conduct testing or some observation lah. For example, groundwater table observation. And using the existing borehole juga, we can install some equipment into the borehole to do some testing lah, like piezometer test and so on. Okay, care in boreholes. So you have to check the level and coordinate. So every borehole that you have made on your ground, on your site, you have to check the level, okay, and then you have to check the coordinate, right? And then sampler, so you have to check all of the sampler in good condition. It must be clean and greased inside. And then sample must be sealed, labeled, and stored. So you have to provide container, okay, and then you have to label each of the container lah. What is the type of borehole, dia punya coordinate, okay, the depth, and so on. And then it must be properly stored. Right, so this is some of the common questions. So how many borings that you have to make on your site? So the number of the boring will increase, depends on the soil variability. Okay, kalau the soil variable, the soil on your site is variable, increases in the variability means that you have to increase the number of boring. Okay, so you have to locate or you have to make more borehole, right? Number 2, as the load increase, right? Just for simple differentiation, for example, you have a single-story building and multi-story building. So of course, for multi-story building, you have to conduct more borehole, right? So as the load increase, you have to increase the number of borehole, right? Last one is for critical or significant structure. Okay, just like I've mentioned in the earlier slide. For example, you construct hospital. So hospital is one of the most critical building. So for that type of construction, you have to increase the number of borehole, right? Because the safety of the construction or the safety of the building is very important. Or if you want to construct building near the cut slope, okay, so it is very dangerous, so you have to increase the number of borehole. Okay, but for boring number, there is a guideline. Okay, there is a guideline that you can refer to. So in that guideline, you can check for this type of construction, for example, for this kind of soil, what is the number of borehole that you need to conduct lah on your site. Okay, what is the spacing, what is the depth, okay, there is a recommendation lah, the recommendation number of borehole, right? How deep? Okay, the depth of borehole we can estimate using this formula. Okay, so you can calculate if the subsurface condition, if your soil is poor means that it is very weak in strength. So you can use this formula lah. Either it is poor or average or it is very good. Good means that it is good in strength. It is very stiff. It is very dense. So it is very good. Right. So this is the general formulation on how to estimate the depth of borehole that you need to advance during exploration. Okay, so this is the picture of core drilling. So core drilling is power operated. It is used for a very hard layer of soil or rock, okay, and then it used together with the drilling bit. Okay, we have various type of drilling bit, either diamond drilling bit, tricone drilling bit, okay, carbide drilling bit, and so on. Okay, core drilling consists of a small diameter hollow tube. Okay, this is the hollow tube fitted at the lower end with a drilling bit. Okay, so kita pasang the drilling bit at the lower end, and then it helps the process of cutting the rock, right? Okay, so this is the picture of sample that they have collected from core drilling. So as you can see here, so this is the rock sample. Okay, so you can take out the sample of rock from the exploration method using core drilling. Okay, so this is other picture of the sample. Okay, next is rotary drilling. Rotary drilling is power operated. It consists of hollow drill rod. This is hollow drill rod with a drilling bit at the lower end, and then all of the rod is advanced into the ground and it is rotated into the soil. Okay, and then we use drilling mud. Okay, drilling mud is continuously pumped into the hole. Okay, so drilling mud will help loosening the soil particle. Okay, so bila the soil particle is loosened, so it is easier for the drill rod to go deeper into the borehole. Okay, and then with the help of bit, okay, the drilling bit, it will grind the soil, and then the soil will retain, can be taken up on the surface, okay, by using the flow of the drilling mud. Okay, so the flow of the water with the drilling mud will return to the surface. Okay, and then from that we can collect the soil sample. Alright, so for rotary drilling we have various size of the equipment. So the bigger the size means that the deeper the borehole that you can advance. Okay, kalau size dia kecil, maksudnya the depth of the borehole is not too deep lah from the ground surface. But if the size of the equipment is big, it can go up to 50 meter, okay, from the ground surface. Okay, next is using wash boring. So wash boring able to provide substantial information of underlying area tested, capable of drilling to 100 meter depth. Normal boring rate can operate to 60 meter depth, right? For wash boring, we can go up the exploration. We can do the exploration up to 100 meter depth lah, from the ground surface. Okay, but for normal boring rate, it can only go up until 50 to 60 meter depth, right? From ground surface. Okay, boring small diameter exploratory hole in fine grained cohesive and non-cohesive soil. So it is suitable for any type of soil, either cohesive or non-cohesive, but it is slightly time consuming. Required 1.5 to 2 days per borehole of 40 meter depth, and then the cost is very high. Okay, so the selection of the procedure of advancing borehole or site exploration is depending on your cost. Kan? Kalau your budget is very high, and then it required the deeper data, okay, deeper the soil data, you might go for wash boring, right? So from wash boring, we also use drilling mud. Okay, so we can use the drilling mud. We can allow the flow of the drilling mud in the middle of the wash boring, and then the drilling mud will brings together the soil sample into the up to the surface. Okay, and then it will return to the top. So from that, we can see the soil sample. It will be mixed together with the drilling mud lah. Okay, so next, this is the picture of percussion rig boring. Okay, percussion rig boring is widely used in United Kingdom. It can provide a borehole diameter of 150 mm to 300 mm. Okay, depend on size of the percussion rig. And then the depth of exploration, it is around 50 to 60 meter. It is consists of derrick, a power winch, and a set of drilling tools, right? Okay, percussion method is used. So this is the procedure. Raise the tool assembly by the winch to 1 meter above the bottom of the hole. Allow the tool assembly to fall under its own weight to drive the cutting tool into the soil. Raise the tool to surface when the cutting tool is full of soil to obtain undisturbed sample. Okay, means that you have to blow. Okay, you have to blow. Once you blow, the impact of the weight will force the drilling bit into the ground. Okay, so dia akan masuk dalam ground. It will drive the drilling bit into the ground. Okay, and then you can raise the tool to the surface, and then you can replace the drilling bit with the sampler, and then you can get the soil sample. Okay, different cutter will be used depending on soil type. For percussion rig boring, we can use it at any type of soil, okay, but you have to change the cutter lah. You have to change the cutter, depends on the type of soil that you deal with on site lah. Either you can use clay cutter, clay auger, sand shell, or baler, chisel, right? And then temporary casing to be used in loose soil condition and for very deep hole. Okay. Okay, next is factors affecting selection of site investigation method. So before this, in the earlier slide, I have shared all of the available method and equipment for site exploration. So you have variable technique and equipment. Okay, and then how to choose the best equipment for your site. Okay, so there are 4 set of factors that you have to take into consideration in selecting the method. Right, so number 1 is geological nature of the site. Number 2 is topographical nature of the site. Number 3 is the type of information required. And then lastly is cost and time. Okay, right, so for geological nature of the site, either the site, the major type of soil is clay or sand, right? So you have to choose the type of borehole, depends on type of soil that you have lah. For example, for clay soil, you might use sinking of borehole. And then for sand, you might use line borehole. And then for firm or compact soil, you might use tri-pit lah, together with all of the supporting equipment. And then if you have rock material, so you might use core drilling. So you can cut the rock, okay, you can explore the rock, and you can also get the soil sample. Okay, number 2 is topographical nature of the site. So depends what is the type of topography of the soil of your site. Okay, so you have to bear in mind the importance of how to move the exploration equipment, okay, into your site. For example, if your site is hilly site, so how you are going to move the equipment, okay, into the site. Right? Kalau you punya site on swampy area, if your site is in the jungle, so the accessibility of the equipment to your site, so that is something that you have to consider lah, the topographical nature of the site. So boleh tak you move that equipment, okay, on hilly side, kan, you nak naik tinggi, boleh ke tak? So depends lah. So you have to select the equipment that suit your topographical nature. Okay, next, number 3 is the type of information required. This is depends on the designer, the contractor, the specialist. Okay, so what type of information that they required. You tak boleh buat semua. You tak perlu conduct all of the testing. Okay, because it is costly, kan. So every test dia ada harga dia. So it depends on the information. So you choose test that is related to the information that you need lah, or your client need, right? And then lastly is the cost and time, right? So this is the most important factors lah that you have to consider, because it involves cost, right? So the deeper the exploration, the more costly and time consuming it will be, right? So if you increase the number of boreholes, so the cost will be increasing. So you have to check what is the optimum number of borehole, method of exploration, the type of method of exploration that is suit your budget of the project. Okay, so it is cost and time. So kalau you increase the depth, for example, increase the depth of the borehole, so means that it is costly and it is also time consuming. Okay, so but again, this depends on your need of the project and also the budget of the project. Okay, Assalamualaikum. So this is the second part of my slide for site investigation topic. Okay, I'm starting with soil samplers. Right, so there are 3 types of soil sample, which is wash sample, disturbed samples, and undisturbed sample. Okay, what is wash samples? Wash sample can be obtained during drilling operation. Okay, when we want to advancing a borehole using drilling operation, we are using drilling mud pump into the borehole, and then all of the soil sample will be bring together to the surface by drilling mud, and then from that we can collect the sample and we can observe, okay, the sample for the description lah. So you can observe the color of the sample and also you can observe the texture of the sample. Okay, so that is wash sample. Okay, and then next is disturbed sample. So normally disturbed sample can be obtained from split spoon sampler from standard penetration test, And you can also determine disturbed sample by simply using hand auger, right? So using that procedure of augering using either manual auger ataupun uh, manual auger or automated auger. So the soil will be drilled and will be forced to the surface, and then we can collect the sample. So the sample is called as disturbed sample also. Okay, next is undisturbed sample. Undisturbed sample, we have various type of sampler. So the first one is piston sampler, and then we can also use thin wall sampler, continuous sampler, and Messier sampler, right? So disturbed and undisturbed sample, I explained in the previous slide. Okay, what is mean by disturbed and undisturbed sample lah. Undisturbed means that we are trying our best to protect and preserve the soil sample so that we can make sure the structure of the soil, okay, the moisture content of the soil is being preserved. And then we have to take a good care of the sample lah, so that it will not be disturbed, right? If disturbed sample means that all of the soil properties like the structure and moisture content is not well preserved. Okay, for disturbed sample, there are type of laboratory testing that is suitable for that kind of sample lah, like to check the grading, right? To check the plastic limit or liquid limit of the soil sample, to check the density, or for compaction testing. For undisturbed sample is more to the mechanical characteristic of the soil, such as the strength, the compressibility of the soil, right? Okay, so the first sampler is split spoon sampler. So this is the most common type of sampler, and then this kind of sampler is being used together with standard penetration test, right? From standard penetration test, we can obtain the number of loads or the N value to correlate the allowable bearing capacity of the soil, and then we can also take sample during that procedure using split spoon sampler. Okay, right? So it is consists of steel tube with a screw thread at each end, and then it is most common type, and then this is the internal diameter. It is suitable for all type of cohesive soil. Okay, why it is called split spoon sampler? Because it has split section. We can open up the sampler, and then we can observe, right, directly the soil sample in the sampler, right? Okay, next is thin wall tube sampler. Okay, so this kind of sampler is suitable for soft sill and clay. They are sensitive to sample disturbance, right? So from this type of sampler, we can produce less disturbance or undisturbed sample. Okay, why? Because this sampler has a very thin, the thickness of the wall of the sampler is very thin, so it can reduce the friction between the sampler and with the soil. Okay. Okay, next is piston sampler. So this type of sampler can be used in soft alluvial silt and clay, and then the internal diameter of the piston sampler is from 35 to 100 mm diameter and length up to 600 mm. Okay, so in this slide, explain the detailed procedure how we connect the sampler with the boring rod, right? So you can read by yourself lah. So from this kind of sampler, Also, we can determine or we can obtain less disturbance of soil, which is undisturbed sample. Okay, so next is Messier sampler. So Messier sampler is 3 tube core barrel containing detachable liners within the inner barrel. So it is suitable for stiffer soil stratum. Okay, and then you can see the picture of the Messier sampler, okay, on the side. Okay, so next is continuous sampler. So continuous sampler, we can get the soil sample to identify sand lenses, and then we can also do the soil description and do the classification testing, okay, from the sample. And then this kind of sampler is suitable for soft marine deposit. Okay, so this is the list of in situ testing or field testing that you can perform on site to determine all of the parameters or soil properties. Okay, so we have here tests for permeability, and then we have a test for shear strength, test for volume changes, okay, the measurement of volume changes, and also test for in situ stress and pre-consolidation pressure. Okay, so for permeability, we can use borehole permeability test. Right, we can conduct field testing or pumping test to determine the permeability test, as we have learned in basic soil mechanics. Okay, the permeability test or pumping test. And then we can also use piezometer permeability test. We can use large scale pumping test, okay, using borehole. And then we can use infiltration test and self-boring permeameter. Okay, and then for shear strength, we can use shear vent test. This is field testing, so we can use that equipment, shear vent test, so that we can directly determine the strength of the soil. And then we can use standard penetration test to determine the N value. From that N value, we can correlate to the strength of the soil. And also pressure meter test, cone penetration test, and also JKR or Macintosh probe test. And then for volume changes, we can use dilutometer test, cone penetration test, okay, plate loading test, piezometer, and screw plate test. And for stress or pre-consolidation stresses, we can use hydraulic fracturing test, pressure meter test, total pressure cell, shear vent, and plate load test. Okay, so this is some of the field testing that we have, and we can perform on site to determine the relevant or the required parameters. Okay, so next we are going to go through the detailed procedure of in situ testing. So there are various types of field testing, but in this code or in this chapter, we are going to detail out only few testing as detailed in the syllabus like standard penetration test, cone penetration test, JKR or Macintosh probe, vane shear, and geophysical testing. Okay, so first we are going to detail out the procedure of JKR or Macintosh probe test. Okay, so JKR or Macintosh probe test, the limited of the exploration is up to 15 meter. Okay, and then the objective is to determine the allowable bearing capacity of the ground. Okay, it is the simple and economic testing method. So normally this testing is used for preliminary design. Okay, for example, for shallow foundation design for a light structure, so you can opt for JKR or Macintosh prop test. Okay, so the method is we are using 5 kg hammer. So this testing is manually operated. So we have a 5 kg hammer attached to the equipment. So freely fall from a height of 280 mm, and then we apply the blows for every 300 mm penetration. Okay, so you have to label the rod with measure the rod and label or tick the 300 mm interval at the rod, so that you can count the number of blow at every interval, right? And then empirical correlation to the allowable bearing capacity can be done. Okay, so we can check the allowable bearing capacity with the numbers of blow that have been recorded. And then you have to stop the test when every interval of 300 mm reach more than 400 blows. Okay, for example, for the next 300 mm interval, your numbers of blows exceeded 400 blows, so you have to stop the test. Or if you reach the maximum depth, let's say you have reached the 50 meter, so you have to stop the test also. Okay, so as you can see here, this is a group of people conducting prop tests. So here, this is the hammer, and then below the hammer, this is the steel rod. Okay, so steel rod is extendable, and then we can join one steel rod to another steel rod with the connector, right? And it can go up to the up until 15 meter length lah. Okay, so the application of the prop test, we can locate shallow bed rock profile within 15 meter. We can locate weak zone at shallow depth. We can also check bearing capacity for shallow foundation and for structure of low risk. Okay, so it is only suitable for light structure. If in doubt, you can opt for borehole, okay, using drilling operation. Right, so the limitation of prop test, the depth of exploration is shallow, not suitable for gravelly ground. So if you exist or encounter gravelly ground during the advancing of prop test, so there will be misleading lah. So you cannot advance the prop into the ground. Okay, so it will stuck somewhere. Okay, and then human error, for example, wrong counting and so on, non-consistent of drop height. Okay, because this is manually operated, so you have to lift the hammer up to the maximum. Okay, but maybe there is non-consistent of the lifting the hammer, so that might lead to the misleading of the result. Okay, exerting force to the drop hammer, so maybe you unconditionally exert the force to the drop hammer. Okay, so that one also will lead to the misleading, and then misleading result at greater depth. Okay, so this is the data sheet of the number of blow recorded for various depth of the ground. Okay, and then this is the difference between JKR prop and Macintosh prop test. Okay, as you can see here, there is a slightly different schematic diagram. So this is the cone. This is the cone of the Macintosh probe and JKR probe. As you can see here, the size and angle of cone is slightly different lah. If JKR probe, normally the angle of the cone is 60 degree, and then the length of the cone is less compared to the Macintosh probe. Okay, for Macintosh probe, the angle of the tip of the cone is around 30 degree, and then the length or overall length of the cone is bigger than JKR probe. Okay, and then you can see a slot. Okay, so this is the slot for root. Okay, root connection lah. So you can join or you can screw the root into the slot here. Okay, so this is the picture of probe tests that have been done in the site. Okay, and then this is the table of the correlation between SPT and also probe test to the bearing capacity of soil. Okay, as you can see here, this is the number of blows recorded for every 300 mm, right? So you can correlate the number of blows with the type of soil and also the bearing capacity of the soil, right? So this N value is for standard penetration test, and then this is the JKR or Macintosh probe test N value lah. So if your number of blows is 0 to 10, so your soil will be very soft, and then the bearing capacity should be around 0.025. Okay, and if your JKR or Macintosh probe around 10 to 20 blows per 300 mm layer, so your soil is soft, and then this is the suggested or recommendation bearing capacity. Okay, so this is for clay. The first table is for clay, and then this is for sand. Okay, for sand, and then N value, this is for SPT, and then this is for the probe test. Okay, JKR probe test. And then from here, you can also correlate to the bearing capacity lah. So bearing capacity is the value that is used to design the shallow foundation. Okay, so this is some of the typical test result of Macintosh or JKR probe test. Okay, so this result also can be used to identify a soft or weak plane, okay, on a slope. Okay, for example, you conduct probe tests on the slope, and then you can identify where is the weak plane of the slope. Okay, weak plane means that you get the very minimum number of blows. Okay, you punya depth tu, so you have to identify which layer you get a very small number of blows. Okay, so the second testing is standard penetration test, SPT test. The purpose of the SPT test is to identify the soil stratification and engineering properties of soil layer. Okay, so this test is more or less like a probe test, but it's using bigger equipment. So it means that the weight of hammer is bigger, and then we can advance the exploration more than 15 meter lah. Okay, depends on the size of the equipment. Okay, so during the standard penetration test, it is possible to take the sample, okay, using split barrel sample, which were used for further laboratory testing. Okay, from probe test, we cannot take the soil sample, but for standard penetration test, we can get the soil sample and then proceed with the laboratory testing. Okay, so this is the picture of standard penetration test. So the hammer is, the weight of the hammer is 63.5 kg. Okay, and then the height of drop is around 760 mm. So it is free fall. Okay, and then as you can see on the right side of the picture is the sampler. So the soil sample can be collected using a split spoon sampler lah during the process. Okay, so for the procedure, we are using 65 kg of free fall hammer from a height of 0.76 meter. So we apply the number of blows. So as you can see here, there is an operator here. So they will lift the pulley, and then the hammer will be lifted. And then when he release the pulley, so the hammer will drop and it will blow the drill rod into the ground. Okay, so you have to count the number of blows for every 400 meter interval. Okay, why 400 meter? Because we consider the first 150 mm as top soil. Okay, so we only count the last 300 mm for every interval as SPTN value, right? So you have to take the SPTN value for every 300 mm interval, right, for soil. And then we can also remove the cone of the standard penetration with the sampler. We can replace the cone with the sampler, and then we can take the soil sample from the testing. Okay, advantage of the standard penetration test, it is simple and rugged equipment, and then the procedure is easy. Allow a sample to be taken. It is suitable for all type of soil and weak rock, and then widely accumulate data and experience for foundation design. Disadvantage, crude, inconsistency in measure, resistant due to variation in energy impact, right? Okay, so this is the picture of a soil sample taken from split spoon sampler. So this sample is disturbed sample, so you can check the detail observation or characteristic of the soil. You can observe the color, the texture, and so on, and then you can bring the soil sample in the lab for further soil classification analysis lah. For example, you can check on the grading, you can check on the plasticity, and so on. Okay, so this is the relationship between SPTN value and the relative density, right? So you can check the N value, the total N value at every interval, and then you can check what is the relative density for the soil, either for cohesionless soil or for cohesive soil. For example, if your soil is sand, and then your SPTN value is from 0 to 4, so the soil is very loose. Okay, if the N value is from 4 to 10, the soil is loose. Okay, and so on, right? Okay, so this is the boring log. So from this boring log, as you can see in the picture, on the left side is stated the depth. This is the depth. Okay, so you can record the depth, and then this is the soil description. So you can take the soil sample, and you can describe on the color, on the texture, and so on, right? And then this is also the depth of the sample that has been taken. Okay, so for example, the description of the soil here is taken at the following depth, right? And then here is the SPT and value. Okay, so there are 6 interval here. 1, 2, 3, 4, 5, 6. 6 interval. 6 interval means that 450 mm divided by 6. Okay, so you have every 75 mm. Okay, so every 75 mm you have to record the number of blue, but the number of blue counted as N value is only the last 300 mm here. Okay, so the first 150 mm, which is 75 plus 75, is not counted as the number of blue. Okay, so here you can see here it is 3 plus 2 plus 2 plus 4. 4, 5, 6, 7, 8, 9. 2 plus 2 plus 2 plus 4. 4, 5, 6, 7, 8, 9, 10. Okay, so the number of blues is 10 here. Okay, and then here the last 300 mm is 2 plus 2 plus 2 plus 2. Right, so the number of blue here is 8. Alright, so that is how we count the number of blue. Okay. Okay, so this is the how we count the number of blue, as I've explained earlier in the previous slide. So we divide the 400 mm, okay, into 6 interval. So this is the 6 interval, so we have 75 mm each, and then the first 2 interval is not counted because it is a sitting drive, and then we only count the total of the next 300 mm as N value. So for example here the N value is equal to 5 plus 7 plus 7 plus 9. That is the N value for that interval, for that layer. Okay, so this is the maximum blows to be applied. So this is the sitting drive. Okay, so this is the sitting drive. So for the sitting drive, the maximum blow is 25, and in test drive, the maximum blow is 50 to 100. Okay. Okay, and then this is automatic standard penetration test. So in the previous slide, I've explained the manual operated standard penetration, which is human operated. So the operator need to pull the pulley so that the hammer will be lifted, and then when he release the pulley, so the hammer will drop. Okay, means that the weight or the impact of the hammer might not be so consistent. Okay, so there is a new technology which is automatic standard penetration test. So it is done by mechanically by a machine, so that the impact of the penetration may be more consistent compared to the previous manual operated standard penetration test. Okay, but the other procedure is the same. The other analysis or detail number of blows is the same. Okay, so this is the SPT correlation between penetration resistance and the strength parameters. So we can correlate the number of blows to the relative density and also the angle of friction. Okay, so we can have a simple guideline what is the strength of the soil. Okay, and then you can proceed lah with the design with what the strength that you obtain. Okay, so this is for cohesive soil, and then this is for sand soil. Okay, so this is actually the graph to determine the overburden pressure of the soil depends on the SPT and value, right? So this is more or less the same like the previous table, but this one is using graph. So from this graph, you can estimate the friction angle lah. So for example here, what is your SPT? Let's say your SPT is 35, okay, and then your overburden pressure, let's say 1.5, okay, so you can check what is the angle of friction. So it is somewhere here. So either you can use the table or you can use this graph to determine the angle of friction lah. Okay. Okay, so this table is the comparison between JKR, Macintosh probe, and standard penetration test. Okay, for JKR probe and Macintosh probe, okay, the size of the cone is more or less the same. Okay, there is no big difference between JKR and Macintosh probe. Okay, more or less the same. Okay, the weight of the hammer also slightly different. So for JKR is around 5 kg, Macintosh is 4.5, and then the height of fall is slightly different, and then the energy is more or less the same, right? But for standard penetration test, the size of the cone is slightly bigger. Okay, for diameter is 50 mm, the area is 1963 mm square, and then the weight of hammer used is 65, the height of fall is 760, and then the energy is bigger lah for standard penetration test. Okay, so the next field testing is cone penetration test. CPT test. Okay, cone penetration test is a static penetration test in which the device is pushed rather than driven by blows into the soil. Okay, for CPT test, the rod with the cone is pushed by the hydraulic pressure into the ground. Okay, for SPT, the cone and rod is driven by blows, okay, into the ground. Okay, for CPT, it is consists of cone attached to a rod protected by an outer sleeve, and then the dimension of the cone is given in the diagram. Okay, the cone is pushed into a soil about 80 mm at a uniform rate of 20 mm per second using hydraulic pressure. Okay, for stage 1, only cone tip is being advanced and the pressure required to push the cone tip. And then for stage 2, with more pressure applied, both the cone tip and the sleeve are pushed down, okay, and pressure. Alright, CPT is quick to perform with fewer performance error compared with SPT. It can provide continuous record of soil condition, right? So this is the data generated by advancing the cone penetration into the ground. So the friction between the cone and also the sleeve of the rod is being recorded, okay? But it has one disadvantage, which is this testing is not suitable for dense or coarse grain soil and mixed soil containing boulders, cobbles, and so on. Okay, so the cone tip is prone to damage from contact with dense object. Okay, so this testing is only suitable for cohesive soil, okay, and not too dense soil. Okay, because the cone is prone to damage. Okay, so from here we can see the CPT profile, and then so this graph shows the depth and also the friction. Okay, so the friction, the side friction, and also the penetration resistance, okay, of the soil. And then from this data we can correlate to the type of soil lah. So we can see if the friction or resistance is higher, so the soil type must be denser, right? Okay, so this is the CPT correlation. So we can correlate the data of the CPT to obtain the shear strength parameters. So this calculation is required lah to determine the undrained shear strength parameters. Okay, so you can use this formula. You can insert this formula by using QC is the cone-based resistance, and sigma VO is the total overburden pressure over NK. This is the cone factors. Or you can also estimate the angle of friction by using the given graph. Okay, so this is the advantage of CPT versus SPT. So CPT provides a much better resolution. It is more reliable, it is more versatile, and then we can also determine the pore water pressure and dynamic soil properties lah from the data. And then the disadvantages of CPT, we cannot get the soil sample from CPT, and then we will not work with soil with gravel, so it is not suitable for gravelly soil, and then need to mobilize a special rig, okay, to move the equipment. Okay, so next testing is piezo cone test. Okay, piezo cone test is a cone penetration test with additional measurement of pore water pressure. So piezo stands for water, so means that the piezo cone is suitable to determine the pore water pressure of the soil, right? So the usage of this test is to obtain the soil profile, the stiffness profile of the subsoil, to determine the coefficient of consolidation of soil, and the result can also be used directly for design. Okay, so it is involved penetration with pore water measurement, give more reliable determination of stratification and soil type compared to CPT. Okay. Okay, and then mechanical properties can be evaluated. So soil parameters, deformation, consolidation characteristic can be evaluated. And then the result from piezo cone can be used directly for the design of pile foundation in clay soil. Okay, so next is vane shear test. So vane shear test is the most versatile and widely used device to obtain in situ undrained shear strength of very soft to firm clay or clay only. Okay, why? Because it is small equipment, and then it's easier to it is mobilized lah. It is easier to take the testing on site lah. Okay, so the manual vane shear test consists of the blade and the rod. So during the test, the blade is inserted into the ground and at certain depth, and then we apply torque, okay, to shear the soil sample. Okay, so from that we can take the reading of the torque lah, and then we use formula to calculate the shear strength of the soil. Okay, so this is the picture of vane shear test using Memo vane. Possible to use the vane test at greater depth. At the previous slides, at shallow depth using manual equipment, but we can also use vane shear test for the deeper depth. So this bench test is connected to the PC and all data is downloaded from the PC. Okay, so this is the formulation on how to calculate the undrained strength of the shear vein test. Okay, so you can use this formula. Right, so the disadvantages of the shear vein test is mode of failure is uncertain, operator dependent, and there might be installation disturbance. Okay, next testing is dilatometer test. This testing is to determine the soil in situ lateral stress and soil lateral stiffness, and to estimate some other engineering properties of subsurface soil. Okay, so this is the picture of the dilatometer test. So this equipment can be inserted into the borehole, and then we can get the result from the testing equipment. Right, so next is geophysical method. It is indirect measurement of engineering properties commonly used to determine soil boundaries, to locate bedrock or groundwater table, detect organic soil, detect presence of subsurface cavities, requires correlation with the bore log, and then there are two common geophysical methods. Number one is electrical resistivity method, and then number two is seismic refraction method. Okay, geophysical method is non-destructive method, means that we do not use normal borehole, or it does not involve drilling or coring. Okay, we do not use borehole, so it use electric current, or it use wave, okay, to determine the soil parameters. Okay, so this is a seismic refraction method. So this method using wave, right? So this wave will travel through the surrounding soil and rock at a speed relating to the density and bonding characteristic of the material, right? So the velocity of the seismic wave passing through subsurface soil or rock material will be determined, and the magnitude of the velocity is then utilized to identify the material. Right, so seismic, we use hammer. So this is the hammer. And now we are going to generate the wave. Okay, so there is a steel plate here, and then you are going to blow the hammer onto the steel plate, and then there is wave will be generated. Okay, and then there are a set of geophone will be located on the ground surface at consistent or constant interval, right? So there is a geophone located at a constant interval. So the time travel for the wave, okay, to reach the geophone will be taken, right? So from that, we can analyze lah the data to check the velocity lah, to evaluate the velocity, okay, based on the time interval. Okay, so this is the correlation between the velocity of the soil and also the type of soil, the type of soil and rock. Okay, so as you can see here for unconsolidated material, so this is the velocity. Okay, so the velocity should be between should be below 90 and 900 meter per second, right? Alright, so you can see lah, if your soil is normal, hard packed, so what is the velocity, right? For water, for loose sand, mixed sand, gravel, and hard clay, and so on, right? And then for rock and consolidated material, so the velocity is more than 2,400 meter per second, right? So maksudnya the travel time from generated wave through the soil and then detected by the geophone is more higher lah for rock and for dense sand. Okay, so the velocity will be very, very high. Okay, so next is electrical resistivity method. So this method is more or less like a seismic method, but this method is using electrical current. So the amount of electrical current through the soil will be recorded and then will be correlate to the type of soil lah. Okay, so this is the picture of electrical resistivity on marine clay deposit. So the same color of the diagram here represent the same type of the soil lah. It gives the same amount of the resistivity, right? So from here we can group the resistivity through for the soil together, and then we can check the soil profile. Okay, so this is the type of material, and then we have the resistivity value. Okay, so from the resistivity value that we can capture from the detector, we can correlate to the type of material, okay, that you have on the site lah. Okay, so we have come to the end of topic 1. So I hope all of my explanation throughout this chapter helps you understanding this topic better. So if you have any question, you can ask me directly, or you can up the question in the group so we can discuss it together with your friend. Okay, so a part of this lecture, I also upload the video of site investigation procedure of drilling and coring procedure in Microsoft Teams. So I hope you can download the video and watch the video so that you have a better picture of how to conduct a site investigation. Okay, so that's all for me. So see you on our next class. Thank you.